The big data challenge we're seeing today is that as cars are innovating with all of these challenges we've talked about, it results in a whole lot more data. So you're looking at cameras that are high resolution, pumping a whole lot of data. You're talking about communication to the outside world, a whole lot of data. So the traditional platforms that automotive had, like CAN, to communicate data, is not sufficient. So, automotive Ethernet is becoming a standard within vehicles to communicate lots and lots of data within the vehicle. Ethernet has been around for 40 years, right? Never hit the vehicle, right? Because CAN was sufficient. But now Ethernet has to hit the vehicle, and we have to solve those problems to allow high bandwidth communication within the vehicle. So why do we need so much data? Why do we need high bandwidth data platforms within the vehicle? Well, we're doing lots of those complex data things. Navigation, lots of map data going back and forth, lots of understanding the world around you and navigating around those challenges. We need to sense the world around us, all those sensors we talked about. We need to be able to control our vehicle around it. Lots of actuators on the vehicle that now have to be controlled. Some of it are manual, some of them are automated. Communication with the world, all the V2X, we're talking to other cars, we're talking to the infrastructure, we're talking to the clouds. And of course, nobody wants to drive around without having their Taylor Swift playlist running. So we have our entertainment, whether that's audio or video or combinations of them. And by the way, 6 passengers in the car. I've taken a road trip with 6 people, all running 6 different videos on their tablets. So there's lots of data being communicated. And by the way, your vehicle is being monitored. So whether that's by you or by the world around us, intentionally, we're sending data back and forth through telematics. So lots of automotive data. But can all that data be too much? Can we have too much data in our vehicle? We talked today, think about it, how many states have outlawed using your phone while you're driving because it's distracting. Well, that's just one little tiny screen, right? Look where our cars are going. And this is Byton. They're building a fantastic car, by the way. But look at all that data. You have a 50-inch screen in front of you, and also one on your steering wheel. So lots and lots of data. But you could run into data overload. I spent a lot of years in the aerospace industry working on fighter jets. And one of the things we were very cautious of is that pilot of that fighter jet has a job to do. He and his life depends on it. And if we bombarded him with too much data on the HUD, he couldn't do his job because the human brain is only capable of absorbing and interacting with so much data. Yeah. So the mission has to come first, right? And if the vehicle is driving itself, great. The driver could, or the human being in the car could interact with those screens a whole lot more. But if you're relying on that driver to have a mission of being in control of that vehicle, you got to be careful how much data you're giving it. So you need to be very careful about providing only the right data at the present time to allow the right response to the present situation. That means you may have a whole lot of data that you don't give access to the driver to, but it's happening in the background. So again, managing your data so you don't give too much distraction to our drivers. And then, of course, all of that data is communicating with the rest of the world, whether that's other vehicles or devices or pedestrians or your home communicating with the grid or even infrastructure that you're communicating with. V2X is talking to all these things, and it all boils down to several different ECUs that have to coordinate that data. So your ADAS ECU has to be able to read info, whether that's an engine or a powertrain, motor, whatever it is, but it also has to actuate on the vehicle. So lots of data is happening at varying data rates, by the way, and varying persistence, right? Think about your GPS. Your GPS, if it had to communicate to maps all over the world, you'd have too much data on your hands. But what does your GPS do? It knows where you are, and it finds the map around you, right? You don't have to know about streets in Colorado today, but you better know about the streets here in Santa Clara when you're driving around. So you find the right data at the right time for the situation you're in. Now, how are these ADAS systems and other autonomous vehicle systems, how are they measuring their success? Well, we're finding today that we're looking at reducing single vehicle side swipe and head-on crashes by 11%. We're reducing our lane change crashes by 14%. And we're reducing our rear end collisions by 40%. This is one that we're spending a whole lot of time on, by the way. Now, there's a big societal question about, will automated driving be safe? And I'm here to tell you, it will be safer than any one of you could ever drive a vehicle, right? Yeah. Of course there will be accidents. Of course there will be conditions that were not anticipated where bad things happen, and that's tragic. But the automated vehicles can respond faster, can respond more reliably and predictably than any human could, okay? We talk about the rare cases where an accident happens, and I'm sure you've heard them on the news, right? You know, Tesla and Uber, you find these, right? Remember two things. One is, these guys are in development programs. They are not fielded products. This happens when you're doing any automotive testing or any testing of developmental technology. It will happen. Secondly is, today, there are about 115 deaths every day on the roads in the US, right? You woke up this morning, by the time you wake up tomorrow morning, 115 people are dead, right? Because of the roads, because of human drivers, right? About 15 to 20 of those are pedestrians, by the way, right? So, should we be concerned about automated driving and the safety of automated driving? Absolutely. But we should be utterly terrified of human drivers. They are out there killing 115 people every day, right? And automated driving is going to be far safer than human driving. So all of this technology requires lots and lots of data, lots and lots of software, and it creates business opportunities for us. The over-the-air updates market is growing by almost 60% over the next couple of years. That's a business opportunity for you, right? How do you leverage that growth in business? Well, one of those areas we're also seeing with big data is MaaS, so mobility as a service. Lots of opportunities for us here in providing the vehicles, in providing the applications of those vehicles. But mobility solutions are becoming consumed as a service. That's leveraged from the idea that consumer ownership model is changing. Cars may be getting more expensive as technology happens, or quite honestly, the price may shrink if the cost of these electronics shift. But autonomous vehicles will create business opportunities as serviceable resources. Now think of it like this. If you had to pay the labor of every person that's out doing a service, right? That's pretty expensive, right? But think about the labor-intensive services. If you could replace them with a robot, which essentially is what an autonomous vehicle is. If you could replace that with a robot, but still make money on that robot, right? You could turn around your return on that investment fairly quickly, especially when you're not paying it as a steady resource. So lots of opportunities there. We're gonna get there by big data. Now, big data has a workflow or a life cycle that we need to think about. You need to create lots of data, whether that's sensing or computing. You're going to get a whole lot of data. You need to communicate that data over networks. You need to aggregate it with whatever standards you're building. You need to mine it and shine it, find all the real data you need, report it, and present it to whoever needs it, and then process it with AI and neural nets and however you're going to compute that data. Once you have your results, you need to act on it with your deep learning and any key decision making you're having. By the way, this is where big technology challenges are happening. And then, of course, we need to protect that data with cybersecurity. So lots and lots of data is happening right now. Let me give you an example. NVIDIA is pulling in data as they're recording a vehicle driving around and trying to do a whole lot of recording and playback for training their autonomous vehicle systems. They report, this is public information, they report that they take 16 terabytes of data on a vehicle in a day. That's a lot of data, right? And then we talk about, well, how do you pull that data out to work on it? Well, there's no real connection to that vehicle that you could pull that much data off in a day. So you literally have to pull the drives out. The RAID disks have to come out. They have to take them in and reassemble them and then use them somewhere else. So you actually physically have to pull the data from the system because it's just so much data you're trying to pull. So when you're looking at these data solutions and data challenges, software becomes a big element of your vehicle. We were at 40%, we're now about 50%. The expectation is that we're going to be moving to 80%. And by that I mean how much budgets of development are happening in software. When I started in the automotive industry back in 1992, we probably had around 20 to 25% of our budget was in software. The rest was in hardware, whether it's mechanical or electrical. So what that means is growing software means our cars are becoming smartphones on wheels. You're basically going to be enjoying the entertainment of your vehicle and not really worried about the mechanics of your vehicle. But what that software means is there's very complex interactions that have to happen in that software. For instance, we talked about cameras and radar being joined together in ADAS solutions. Well, that data has to be fused and it has to be synchronized when it's fused, because you have to make sure that what you're sensing, if you're fusing data from a radar and a camera, it better be synchronized for your ECU to understand what is actually going on. So it's not just lots of data, it's not just complex software, but now the time element comes into play, and it better be synchronized data. Furthermore, when you're looking at how data is going to improve your testing, there's lots and lots of data that has to come in from various scenarios. So it takes big data to solve these big challenges. These scenarios we're showing here in the image generation have to be tested. Well, how many scenarios are good enough, right? We talk about NVIDIA taking 16 terabytes of data. That's because they're capturing so many different scenarios to build their training set. Your training sets are growing, which means your data sets are growing. And SAE and other government agencies are looking at how do we standardize on what those data sets are that you have to test to. But I'm going to tell you that every corporation that's out there is going to treat that as a minimum, but they're going to do a whole lot more testing on their own data beyond those standards, because those standards will always be evolving as new incidents happen. So there will be deep learning that happens when we capture all this data, and we have to work with it. So your environment perception is going to be the key to autonomous driving, but our ability to interrogate and infer from that environmental data is going to evolve. And we're going to have to learn and build training sets around it. So our traditional efforts don't scale to these various scenarios we're going to do. So we're going to have neural nets to learn the efficient processing of data, and the autonomous vehicle algorithms are going to build AI into those systems. So our inductive learning has to evolve our software as the systems learn to challenge these test environments. So when we test that development, of course that means that we have to try all kinds of different scenarios. Now, the leader by far in doing road tests is Waymo. Waymo has 8 million road miles, and look at how they've scaled over the last few years. 8 million road miles of testing. But that is completely shadowed by the sim testing that they've done. So they've simulated 5 billion simulation miles. Now, it takes a lot of time to get 8 million road miles and a lot of resource and a lot of money. Of course, simulation is a whole lot cheaper. So sim testing is less expensive, but it's also less realistic. There's no substitute for real field testing. But you start to wonder as a business, how much of my testing can be done in sim versus the road? And there are areas where you start targeting simulation tests. So you would do simulation tests first off when the testing is too dangerous to be doing in person. Secondly, when you're confident in your model. and your fidelity and accuracy of your model. And secondly, thirdly, when your data set and your test cases are huge, right? We're talking thousands, millions of scenarios. You can't go out and test that with a vehicle. You can't even set it up. So you're going to simulate that. But you will have to use real tests. First off, you do it when it's simple and easy to do. Sometimes it's better, hey, let me just get out in the car and try it out. You'll have to use it when your model is impractical, and you're also going to have to use it when it's safety critical. In other words, your simulation can't be trusted. I need to know for darn sure that the vehicle's going to respond this way. So there's going to be use cases for sim and real tests. So the trade-offs are you're going to use simulation. It has it's software only, so it's easy to implement, but it doesn't really emulate the world. You'll use emulation, such as hardware-in-the-loop testing, as kind of a nice bridge to field test. So simulation is easy, but doesn't simulate the real world. Field test simulates the real world. It can be difficult to set up, and it can limit your test coverage you can do. So really the happy medium where I see a lot of customers or a lot of OEMs in the automotive space is in the emulation world. You're emulating the real world with real hardware-in-the-loop techniques. You can scale this, so you can just chain a whole bunch of these together and run your tests overnight. But it does require intimate knowledge of the real world and intimate knowledge of your simulation. But this is the best you can get in a scalable way. So that's how testing is happening today. Some of our customers we're dealing with are doing that approach right now. Mazda is one of them, and he reports things like, hey, I reduced my testing by 90%. And when you could reduce the testing effort and cost and time by 90%, you're onto something. And he's simply moving from real world tests into lab-based testing. So what can you do? Let's finish off with opportunities for you to make some money in this changing environment. First off, go off and research what areas you're interested in. Find out how the industry is changing, things like you're doing here today. Find out the opportunities you have. Then collaborate. These are big challenges that are probably bigger than you alone. So find out who you're going to work with to solve these challenges. Go innovate those solutions. Build solutions that you could release, and when you're innovating these, think MVP, think minimum viable product, right? That's how people are getting out there in this industry today. Go launch it, find some lead customers and earlier adopters for you, and then adapt to things as you learn and as technology changes. That's the basic flow you're going to use. And we're seeing it today as we're trying to shift along this curve of automated driving. We're really kind of between 2 and 3 today. So this is the SAE standard for automated driving, from no automation all the way to full automation. And as you can see by this cartoon graphic here, there's increasing determinism and bandwidth needed, so there's lots of data challenges as we grow through these stages. In these early stages where there's really a human driver that's monitoring the driver environment, we're getting through here today with ADAS, right? So we're up to 2 pretty easily. But as we're moving into actually automating the vehicle and taking control of it, it requires lots more data and lots more testing to certify that to functional safety standards. So that's why this gap from 2 to 3 is really hard for us today. But that's where the opportunity is for you as a business. And where can those opportunities lead you? Well, your solutions can address that automation in your autonomous vehicle. How are you going to help build autonomy into your system? You may look at things like MaaS, right? Mobility as a service. Look at all these startups in this area that are growing, Uber and Lyft and Waymo, and they're finding out how we can create that as a service. Also think of your demographics. Do you know that today there are 47% less 16-year-olds that have a driver's license than just a few short years ago? Today's 16-year-olds aren't beating down the door to get their license anymore. They don't have too many opportunities to not need a license. Think about training data. How many of these solutions need oodles and oodles of training data? Think about the 16 terabytes of data that NVIDIA is pulling every day per vehicle. That's the kind of thing you can go make some money on. Think about your financial areas, tolling and charging, and your vehicle, electric vehicle charging. Think about the car repo man of tomorrow, right? If you don't make your car payments today, hopefully none of you have experienced this, but a repo man will come and put your car on a tow truck and haul it away, right? Tomorrow, if you don't make your car payments, well, first off, the car will try to charge itself, right? It will just make the transaction for you. But if you don't have any money in your account, guess what the car does? It'll just drive back to the lot, right? It'll go back to whoever owns that, right? That will be the interesting one. You may go out there, get in your car, and it just won't run, right? It just kind of bricks your car for you. And by the way, bricking cars is happening today. So that technology is happening today. So lots of opportunities in financial. Optimizing things, optimizing your charging, optimizing your performance, optimizing your driving. Safety elements. If any of you hear of the standard ISO 26262, it's a functional safety standard derived off the aerospace functional safety standards. Autonomous vehicle companies are struggling with that. Can you be a business to satisfy that? Can you take the test cases that are needed to satisfy safety standards and deploy them to autonomous vehicles? And of course the convenience, right? Everybody will pay for convenience today. Build an app to help them drive themselves. And then I'm going to leave you on one quick story here. When I first got into the electric vehicle market, it was in the early 90s, and I was selling a hybrid electric vehicle to the Army. And I remember building this proposal. I spent oodles of time trying to build the best sales pitch to these guys. And then this was a hybrid electric vehicle, and I was pitching to the military, the Army decision makers. I'm going to reduce your fuel consumption by X. I'm going to reduce your maintenance by Y because I have regenerative braking on this vehicle. You're going to save so much money in this operation that you're going to get the return on your investment to buy this vehicle from me in just a few short years. And I pitched that hard. I was young and naive, and I thought that's what they wanted. And as we talked about the features, they said, wait a second, you have a generator on this? I said, yeah. They said, does that power come out? I said, yeah, we have, all that power is available for your use. Can you make AC so I could plug my coffee pot into it? Yeah, I could do that. You could put AC on this? Yeah, so you could plug your coffee pot in. They say, wait, how much power comes off that engine? I said, well, about 60 kilowatt. And they said, well, we tow around a 60 kilowatt generator. Would I be able to park that and use that now as a generator? They said, yeah. I said, yeah, sure, go ahead. So here I go pitching the operation use of this vehicle. And this customer was thinking about, I don't care about the maintenance, that's free for me. I don't care about the fuel, it just shows up. What I care about is I could plug my coffee pot into it, and I don't have to tow around a 60 kilowatt generator anymore, because your vehicle now becomes a generator, right? So what I want you to think about is all the data that you're finding and creating, your customers will find innovative uses of your data and find value in your product that you can't even imagine yet. So even if you think that your solution has only a little bit of value, talk to people about it. People outside of your community may find value in that data that you haven't even imagined yet. So I'm going to leave that here and open up for any questions if there's any time.
No, you have done an excellent job using all your time there. Very well. And you did a great presentation and applause. And then he is on the board of PMI. He's on the board of Society of Automation Engineers. Were you all IEEE as well? Were you from the VTA Society?
Yes.
Okay, because I was on the board of IEEE also.
Oh,
I've been on the board of 6 societies.
Wow.
So,
Wow.
I have no life. Yeah.
And we have a panel on this topic this afternoon.
Okay, so make sure you come back and listen to more of him.
Right.
Great job.
All right, thank you so much. Thank you.
Appreciate it. Okay, I'm going to be